Alright, hello, this is Mrs. Reed, and this is lesson 5.2, Exterior Angles of a Polygon. Our objective for today, I discovered and can apply the sum of the exterior angles of a polygon. Investigation 1. Step 1. Given the pentagon, what is the sum of the interior angles? So what we learned last time is that the interior angles of a pentagon add up to 540 degrees. And if you forgot how we do that, just do 180 times 5 minus 2. Use the angle measurements and the polygon sum to calculate the measure of angle x. So this is what we're trying to find right here. And we have 540. And so if we just subtract out each of these angles, minus 99, minus 117, minus 90, minus 146, then whatever we have left over will be x, which if we do that correctly, we should get 88 degrees. Using the linear pair conjecture, calculate the measure of each exterior angle, so those are on the outside. And we know that x is 88, and then if you remember, the linear pair says that the two angles should add up to 180. So if I do 180 minus 88, that will give me 92 here. If I do 180 minus 146, I'll have 34. And then 180 minus 90 will give me 90. And then 180 minus 117 would be 63. And then 99, or 180 minus 99 will give me 81. So now if we add all of those up, 92, 81, 63, 90, 34, we get 360 degrees. So the sum of the exterior angles is 360 degrees. Investigation 2. Step 1. Given the hexagon, what is the sum of the interior angles? So remember that formula that we learned last time. I'd like for you to go ahead and figure out what the sum of the interior angles of a hexagon is, please. So hopefully you either remembered or looked back at your notes. So we do 180 times n minus 2, and n is the number of sides here, which is 6 for a hexagon. So 6 minus 2, which is 4. So 180 times 4 would be 720 degrees. Step 2. Use the angle measurements and the polygon sum to calculate the measure of angle x. So right here is what we're trying to find. So we know that all of these angles on the inside add up to 720 degrees. So we're going to take 720 and we're going to subtract all of these interior angles out, because then whatever is left over should be x. So 720 minus 130 minus 90, just working my way around, minus 140 minus 150 minus 90. Subtract all of those from 720 and we get 120 degrees. So x is 120 degrees. Step 3. Using the linear pair conjecture, calculate the measure of each exterior angle and label it on the figure. So go ahead and take a moment right now and use linear pair, so that means that the two angles together, so like from here to here, it should add up to 180. So you need to figure out what the exterior angle is for all 6 of these exterior angles. So take a moment and go ahead and do that. Alright, so you should have gotten 50 and 90, 40, 30, 90, and 60. Step 4. Find the sum of the exterior angles. So if you add up 60 plus 50 plus 90 plus 40 plus 30 plus 90, what do you get? Go ahead and do that, please. Alright, so you should have added those all up and got 360 degrees. Which leads us to the exterior angle sum conjecture, which states The sum of the measures of a set of exterior angles is always the value of 360 degrees for any polygon. So the outside angles, those exterior angles, will always be 360 degrees. Investigation 3. If the exterior angle sum conjecture states that the sum of the exterior angles of any polygon is 360 degrees, what is the measure of each exterior angle in any equiangular polygon, where all angles inside the polygon are congruent? So looking at the first one, we have a triangle, and we know that all three angles on the inside are congruent, which means all three angles on the outside are congruent as well. And we know that any polygon, the exterior angles will add up to 360 degrees. So all three of these should add up to 360, and we know that they're equal, and I have three of them, so just divide 360 divided by 3 and we get 120. So each of these exterior angles on a triangle are 120 degrees. So go ahead and try the square to our right here and figure out what all of these exterior angles would be, please. So to do that, you would take 360 and divide it by 4, because we know that all four of those angles are congruent and they need to add up to 360 degrees, which gives us 90. So all of these exterior angles are 90 degrees. Alright, the next one we have a pentagon, so a 5-sided figure, and all of them are congruent, so go ahead and figure out what the exterior angles would be, please. Alright, so you should have done 360 and divided it by 5, which gives us 72. So all of the exterior angles of this pentagon are 72 degrees. Alright, next one. This is a 6-sided polygon, so it's a hexagon. Go ahead, take a moment and figure out what each exterior angle would be. So you should have done 360 divided by 6, which gives us 60. So each of these exterior angles are 60 degrees on our hexagon. Write an equation for the measure of each exterior angle for any equiangular polygon. So all we did each time was 360 divided by the number of sides that we had, and n is the number of sides, which is actually the same as the number of angles. Investigation 4. If each exterior angle can be found by using 360 divided by n, how can we use that to find the adjacent interior x, knowing that the polygon is equiangular? So we have an example here to help us think this through. So this is a pentagon, and all of the exterior angles are congruent, assuming that this is equiangular like it says. So I would do 360 divided by 5, which will give me 72. So each of these exterior angles is 72 degrees. Let's write that in there. So now to figure out what x is, we would just use linear pairs and do 180 minus 72, which is 108 degrees. So if the sum of any polygon's interior angle is found by the formula 180 times n minus 2, how can we use that to find just one interior angle of an equiangular polygon? So we would just take the sum of the interior, which is 180 times n minus 2, and divide it by the number of sides, which in this case is n. So you can find the measure of each interior angle of an equiangular n-gon by using either of these formulas. So 180 times n minus 2 will give us the total of the inside. But if we divide it by the number of sides, that will give us just one of the interior angles. The other formula that works would be using the linear pairs, which is 180 minus whatever that outside angle is, which would be 360 divided by n. And again, where n is the number of sides or angles. Solve for the unknowns using your formulas. So for this first one here, we have a 5-sided figure, so a pentagon, which would be 180 times 5 minus 2 to determine what the interior adds up to. So that's 180 times 3, which is 540. And now to figure out what x is, we need to do 540 and subtract all of the interior angles that we know. 1, 2, 3, 4. Got them all. So 540 minus 68 minus 121 minus 103 minus 85, we should get 163 degrees for x. Alright, so for this next one, I want you to go ahead and give it a try to figure out what angle Q is right here. So take a couple minutes and do that one, please, and then we'll check to see that we got the same thing. Alright, so you should have done 180 times 4 because there are 6 sides, so 6 minus 2 is 4. 180 times 4 gives us 720. And then if you subtract all of the interior angles, you should get 130 degrees for angle Q. Alright, this next one we have a pentagon, which we know adds up to 540. They gave us all of the angles, they just threw in an unknown variable x. So let's just write out what we know. 3x minus 5 plus 4x minus 8 plus 91 plus 125 plus 92. All of that added up should give us 540 degrees. And this looks really gross, but we can actually simplify it pretty well by combining like terms. So I'm going to start with 3x and 4x, which will give us 7x. And then we have negative 5, negative 8, 91, 125, and 92. Which if we combine all of those like terms, we get 295. So plus 295. And that still equals 540. So I'm going to subtract 295 on both sides. Running out of room here, I'll go over here. So 7x equals 245. So then we divide by 7 on both sides. And so x equals 35. So then if we plug x into our expressions there, 4x minus 8. So 4 times x, which is 35, minus 8. 4 times 35 gives us 140, and then minus 8 more, we get 132. So this angle right here is 132 degrees. Let's do the same thing over here. 3 times x, which is 35, minus 5 more. So 3 times 35 is 105, and then we subtract 5 and we get 100. So 100 degrees right there. Alright, this next one we need to figure out what y is. And all of the exterior angles, if you remember, for any polygon add up to 360. So even though we know this is a very strange looking pentagon, it doesn't actually matter because it adds up to 360 anyway. So 360 minus 70 minus 60 minus 65 minus 40 Subtract all of those and you get 125. So y is 125 degrees. Alright, so for this next one, we have a four-sided figure and all of the interior angles are given to us just with an x involved. So to figure out the total of the interior, we would do 180 times 4 sides minus 2, so 180 times 2, and get 360 degrees. So we know that 89 plus 5x minus 8 plus 3x plus 4 plus 51 should equal 360 degrees. So let's go ahead and combine some like terms and then solve for x, and then use x to figure out the two missing angles. So I'll give you a few minutes to go ahead and do that, please. Alright, so you should have gotten x equals 28, and then from there you need to plug it into the two expressions we have to figure out the two missing angles. Alright, so 5x minus 8 would be 5 times 28 minus 8. We would get 132 right here. And then 3x plus 4, we'd plug in 28, and then we get 88 degrees right here. And if we do 88 plus 132 plus 89 plus 51, we get 360 degrees, which we know a quadrilateral, the interior angles all add up to 360 degrees, so we are correct. Alright, so to do this question here, go ahead and put these hash marks here. Now this problem is actually doable. And the first thing I'm going to notice is that we have a 90-degree symbol here, which means x is 90 degrees. And then we also know that this angle over here is y. So all of the angles on the exterior added up together for any polygon add up to 360 degrees. So we have 90 plus y plus 75 plus 67 and plus y. All of those added up together should give us 360 degrees because they are exterior angles. So we're going to go ahead and combine like terms and solve for y. So why don't you go ahead and do that, and then we'll check to see that you have the same thing that I get. Alright, so you should have gotten that y equals 64, which means 64 is also over here. And if you do 90 plus 64 plus 75 plus 67 plus 64, we get 360 degrees. So we know that we did this one correctly as well. And here is our summary for 5.2, which we will go over together later. And this concludes our lesson 5.2.